inverse of sine s from first principle. So you write solution. So what you do, it means that y is equal to sine s. So you call it equation 1. The next step, any place you see y, this y will now change to y plus change in y. Y, any place you see s, this s will change to s plus change in s. So we are going to have y plus change in y will be equal to sine s plus change in s. The next step is that we are going to now subtract y from both sides. So you write subtracting y from both sides. So if you come here now, you have y plus change in y minus y. So if you come to this side, you have sine s plus change in s minus y. So this one we cancel this. Our aim is to make change in y the subject of the formula. So you have change in y will now be sine s plus change in s, then minus from equation 1, y is sine s. So instead of writing y, you write sine s. So the next thing is that, let me call here equation 2. So let us now expand this. Because anytime you have brackets, sine, so you go to trigonometry. So you now say but from trigonometry we have that if you have sine a plus b, the formula says that is going to give you sine a cos b plus sine b then cos a. That is the formula. So what you do now, you compare this and this. So we now say let our a be equal to this x, and let our b be equal to change in s. So it means any place you see s, a, you put s. Any place you see b, you put change in s. If you do that, we now say from equation 2 now, from equation 2, so from this equation 2, we are going to have that change in y will be equal to, so instead of writing this now, we expand it. So we are using this formula to expand. So what you do now will be, you write sine s. Instead of writing a, you will now be writing s. Because if you compare this and this, they are the same. So you now write cos change in s, because our b is now changing s. Then plus sine change in s, then cos what? S. Then this one just expanding only this one, but we still have minus sine s. So you now write minus sine s. So the next thing is you collect like terms. Look for those terms that have the same thing. If you watch, the first term has sine s, the last term has sine s. So we now say collecting like terms. So you collect them together. So it's going to give us change in y will be sine s cos change in s. So this one will go minus sine s, then plus sine change in s cos what? S. Are we together? Now what you do now, you do what? You factorize. Factorization means you bring out that thing that is common between these two terms. So when you factorize, sine s is here, sine s is here, you bring it out. So it's going to give us sine s, you open bracket, So the whole of this divided by this sine s will cancel this sine s. It's not going to give us cos change in s. Then minus sine s divided by sine s, you're going to have minus 1. Then plus sine change in s cos what? S. The next step is what? You divide both sides by change in s. So you write dividing both sides by changing s. So when you divide both sides by changing s, we are going to have changing y over changing s. Then I'll be dividing 10 by 10. So, and if you come to any term, try to divide that side that has changing s. So if you come here, you have sine s into cos changing s minus 1. So I will divide this by changing s. Plus, if I come here, I'll say sine changing s. I'll divide this by changing s. I also have cos s. The next step is what? We are going to take limit of both sides. Taking limit of both sides as what? As changing s tends to what? 0. If you do that, you are going to have the limit as changing s tends to 0 of changing y over changing s. You come to this side, so you're going to take the limit 10 by 10 separately. So if you come here now, you have the limit as changing s tends to 0 of sine s, then times this one, the limit as changing s tends to 0 of the whole of this, cos changing s minus 1 all over changing s. So what again? Plus the limit as changing s tends to 0 of what? Sine changing s over changing s. Then times the limit as changing s tends to 0 of what? Cos s. Then what again? Anytime you take the limit of this, it's going to give us the y over the s will now be equal to. Now, limit of a constant is constant. So if you take the limit of it, there is no change in s here. So it's going to give us sine s. Then times. If you watch here now, because if I put 0 here, because the change in s here is now 0. Cos 0 is 1. Watch very well. Cos 0 is 1. 1 minus 1 is 0. And 0 divided by 0 is undefined. Anything divided by 0 undefined or it does not exist. So it means this one does not exist. Infinity. So infinity times any number is infinity. So this side doesn't exist. Even if it's 0, 0 times anything is 0. So you say plus, you concentrate here. And there is a formula that says that when you take the limit as changing s tends to 0 of sine changing s over changing s, the whole of this will give you 1. When we treat limit, I will prove this formula there. Well, just if you treat limit, go and pick that of the limit, you will see where I prove this. So if you borrow from that place, we got that the whole of this will give us 1. Because once you take the limit of sine, even if it's sine a over a, as a tends to 0, the answer is 1. It is provable, we proved it. So this will give us 1 times, there is no change in s here, so take it as a constant. So the limit of it will still be cos s. So we now say that the y over the s will give us, this one is not there again, 1 times cos s is cos s. That is the answer. So let us quickly look at, let us see how to differentiate that of cos s. So if you are asked to find from first principle the y over the s of y is equal to cos s. Remember, if you differentiate sine s, you get cos s. So let us now differentiate cos s and see what you are going to get. We start again. You write solution. Once you write solution, plus change in y. Any place you see s, that s will change to what? S plus change in s. So we have cos s plus change in s. Next step, you subtract y from both sides. So you say subtracting y from both sides. If you do that, you have y plus change in y minus y. My aim is to make change in y the center of formula. So you have cos s plus change in s minus y. So this one will cancel this. So you have this s plus change in s minus our y from equation 1 is cos s. So you remove that y and put cos s. So we are going to expand this. So let's call this equation 2. Equation 2. So expanding this, because there is bracket there. So you are also going to use sine of cos under compound angle. If you go to trigonometry, you see compound angle. The sign says, but if you have cos A plus B, the formula says it's going to give you what? It's going to give you cos A cos B minus sine A sine B. So that is the formula. So we now say let our A be S and our B be equal to change in Y. Change in what? This bracket, it means that you will now write from equation 2 now. From equation 2, from this equation 2, you have that change in Y will be. So instead of writing this, we shall be writing this. But if you see A, it will be S. If you see B, it will be change in S. So it's going to give us cos S, cos change in S, minus sine S, sine change in S, then we have minus cos S. At this point, what do? You collect like terms. This and this, they have like terms. You say, collecting like terms. So when you collect like terms, you have change in Y will be cos S, cos change in S, minus cos S, minus sine S, sine change in S. What again? We now factorize. Cos S is here, cos S is here, you bring it out. So you have cos S, you open bracket. The whole of this divided by this, it will give you cos change in S. Then minus this divided by this is 1. They now have minus what? Sine S, sine change in X. Keep on moving. Keep on moving like that. Both sides by changing S. So when you divide both sides by changing S, you have change in Y over change in S. Will be equal to, so the whole of this is 1 term, but I will divide that one that has change in S. So you have cos S into cos change in S minus 1 all over change in S. Then minus sine S, sine change in S. I will divide this one by change in S. Okay. I will divide that one by change in S. The limit to 0. When you do that, you have here that the limit as change in S tends to 0 of changing y over changing s will be equal to the limit as changing s tends to 0. You write your cos s, then times the limit as changing s tends to 0 of cos changing s minus 1 all over changing s. So minus the limit as changing s tends to 0 of what? Sine s, then times the limit as changing s tends to 0 of what? Sine changing s over changing s. So the whole of this will give us that the y over the s will be equal to what? Then this is constant, right? Cos s, because there is no change in s. Then times the same thing again. Cos 0 is 1, 1 minus 1 is 0, over 0 does not exist. So the whole of this is 0. We have eliminated that. So minus the limit of this is sine s times, from what we did before, this will give us 1. So times 1. So we now have that the y over the s will give us minus sine s. So we have seen that if you differentiate sine s from first principle, you get cos s. If you differentiate cos s from first principle, you get minus sine s. Don't forget this, because when we enter general principle, we shall be making use of these two rules. So the next one will be tan s.